feeling the heat here recently, and we're going to delve into that. And to do that, we're going to first understand what geopotential heights are and what we mean by height anomalies. So what we're really looking here is 500 millibar geopotential heights here, and what all that means is 500 millibars is basically about 3 miles above the atmosphere. It is a surface plane of pressure. So when you go up a certain amount of height in the atmosphere, you get to 500 millibars. This is basically how high 500 millibars is. It's about 3 miles, but why we call these geopotential heights is because, well, they're actually how high this pressure surface is above the surface. So when you have a higher height, that means it's higher above the surface. A lower height means it's a little bit closer to the surface. It's almost a way of seeing it as almost kind of like a way of showing pressure in a way. So imagine this, we have lower heights, it kind of equates to lower pressure, higher heights equates to higher pressure. Not exactly correct, but it is a general idea to kind of understand the dynamics with this. And why we say look at 500 millibars is, well, if you've seen a map like this, I've shown this many times, it's the upper level pattern. This is where the jet stream is. That's why 500 millibars is said a lot. It's basically the level in the atmosphere where we're seeing that jet stream. It dictates these large-scale patterns in our atmosphere, and that includes some heat waves, cold blasts, storm systems, things like that. So let's go back to this. So here we are. We have a 500 millibar height. Basically, this is where the jet stream is, and this is what we could call a normal setup. Now, this is more of an example, but it gives you an idea of what it could look like. Now we're going to change this a bit, and notice these lines move up, and notice as you go down on this line, the bottom line has the highest height, so you notice this ridging effect. And you know with the jet stream ridging, that equates to higher geopotential heights. And when you have lower geopotential heights, as you saw there, it troughed down over the western parts of the U.S. That's where we have troughing occurring. And this is where we go into the anomaly. So when you have higher geopotential heights, or when you have a ridge developing, you see anomalously high heights, and quite the opposite case, vice versa, lower heights when you have troughing. So when we talk about anomalously low or high heights in this case here, what is basically ways of visualizing basically when the jet stream is troughing, making those dips, or when the jet stream is making those ridges. And when you see a ridge, you usually have warmer, drier weather. Troughing, usually that's when you start seeing some of the more unstable weather, some of the cooler weather as well. So let's now talk about climate, because what's been going on in our climate has been dictating why we've been feeling this heat. We're going to look first over here at the Pacific Ocean. This what this climate is called is the Pacific North American pattern, PNA for short. So this is our normal jet stream, but now we notice it changed. Now is what we call the positive phase. And in this case, we have anomalously low heights over the Aleutian Islands. Basically, the jet stream is troughing more, but over the western parts of the United States, it's ridging more. Vice versa, the negative phase, you have the ridge over the North Pacific, you have the troughing over the western parts of the United States. We're going to leave it here, the negative phase, because that's where we have been recently in the Pacific. Now we're going to look over here at the Atlantic, because guess what? Things in the Atlantic Ocean are also going to impact here in the Northland. So here's our normal jet stream, and you'll notice it's going to ridge now. That's what we call the negative phase, is where we have a ridging over around where Greenland and Iceland in. The positive phase is the opposite of that, where we have more of that troughing effect. We have lower geopotential heights over Iceland and Greenland. Now we're going to leave this in the positive phase. Now we need to look at what's going to do here in the Northland, because you have basically this dip in the jet stream out towards the west thanks to the Pacific North American oscillation. You have this dipping over the North Atlantic thanks to, again, the North American, or I should say, the North Atlantic oscillation. So yes, these oceans, I mean, these are one bigger oceans in the world, and they're impacting the Northland because of how waves work. You see the ridging developing under the jet stream here, and that's what we're seeing here in the Northland. We're seeing basically that ridge over the Great Lakes region. We've been seeing that because of these climate modes. So our climate across the planet does affect us here in the Northland. In fact, here's the height anomalies as the beginning of October. Here is the Pacific North American phase is in the negative phase, like you can see there, and over here the North Atlantic oscillation is in that positive phase, and that's creating this right here, those high geopotential heights. Also know is the jet stream has been ridging quite consistently over the north central United States, and has been allowing those really warm temperatures to continue sticking around here in the Northland. And